All right. So we're doing part two of the stats vocabulary. So we're picking up where we left off. And we're going to start right here where it says factors that can ruin experimental results. We're going to start with this where it says confounding variables. Uh-oh. Factors that can ruin experimental results. And we're going to talk about confounding variables. Confounding variables occurs when an experiment occurs when an experiment cannot tell the difference between the effects of different factors on a variable. So, for example, a restaurant does a full remodel. Of the facilities. There's major street construction that shuts down the roads to the restaurant. On reopening night. On reopening night, only a few customers show up. The effect of the remodel and the street construction have been confounded. So we don't know if people didn't like the remodel or if people were turned away because of the street construction. So we don't know what actually affected them not showing up. All right, the placebo effect is when a subject reacts favorably to a placebo when in fact the subject has been given no medicated treatment at all. That's what a placebo is. It's basically like a sugar pill. So some studies have what they call placebos. So they give some patients the real drug and some patients a placebo, which is basically a sugar pill. And they try to see the difference between them. And so when a subject does well on the placebo, then they're not sure what happens here, because really the placebo is like a sugar pill. They say they're not really sugar pills, but they're like sugar pills. And then they do well. So a participant in a study, so they report the participant in a study to measure results on eliminating migraines is given a placebo, which means there's no medicine, but reports her symptoms improve. So these are things that throw off a study, okay? So what are things that we need to consider if we're going to design a study? So first, we need to identify the variable of interest, the focus, and the population of the study. Then we're going to develop a detailed plan for collecting the data. If you use a sample, make sure the sample is representative of the population. That means it's not skewed or biased, representative. And then we should collect the data and then describe the data using descriptive statistic techniques. Then interpret the data and make decisions about the population using inferential statistics. So we need to infer something and identify any possible errors. Okay, so there are several methods of data collections. So we could do an observational study. And when we do an observational study, a researcher observes and measures characteristics of interest, of part interest. I stopped writing here, sorry. Of part of a population but does not change existing conditions. So they're just looking. They're just seeing. They might sit on the side of the, in the cafeteria, and how many people wear hoodies? Okay, an observational study. So biologists want to learn about specific animals. In their own habitats. So they're just watching the animals in where they live. Would use observational studies. Okay. We could perform an experiment. If we perform an experiment, a treatment is applied to part of a population. and responses are observed. Another part of the population could be the control group. Where no treatment is applied. Or some given a placebo. While others given the treatment. So an example would be pharmaceutical companies. You know, the people, the drug makers. They use experiments to effects of medication on patients. We could do a simulation. This is the use of mathematical or physical model to reproduce the conditions of a situation or process. So like when we do our stat edit, stat calc. So automobile companies use simulations with crash dummies. To study the effects of crashes on humans. We could take a survey. Those are really easy. This is basically an investigation of one or more characteristics of a population usually you just ask questions. But questions should be worded carefully. To avoid bias. So, asking people that are leaving a restaurant about their satisfaction. their dining experience. Okay. Now, there's some things you have to be careful of because you can get what's called biased or unbiased results, and you want your results to be unbiased. You don't want people to tell you. You don't want them to be skewed towards things that are. You don't want them to be skewed. You don't want them to be towards one way when you really want them to be everybody's own opinion, not your opinion. So you can have what's called blinding. This would be a technique that results in unbiased example. So this is where subjects do not know whether they are receiving a treatment or placebo. So like, for example, giving a subject 2 cups labeled A and B and asking them to taste both. And determine which is Pepsi and which is Coke. They did this in a commercial. That's blinding. A double blind experiment is when neither the experimenter or the subjects know if they are receiving a treatment or placebo. So, for example, pharmaceutical companies, so drug companies, can formulate their medications and placebos to look alike. And no one knows what they're getting, what they're giving or they're getting. All right. Randomization is a process of randomly assigning subjects to different treatment groups. So, for example, assign a number to each subject. And then choose numbers at random. Sometimes I do groups that way. Randomized block design is dividing subjects with similar characteristics into blocks. And then within the block, randomly assigning subjects to treatment groups. So for example, sorry about that. Too far. Oh, let's see. Before testing a new weight loss drug, weight loss drink, group subjects by age or gender. Then random assignment. Matched pair design is subject are paired according to similarity. Subjects paired according to similarity. One subject in pair is randomly selected to receive one treatment while other subject receives another treatment. So for example, subjects paired by age receive two different treatments. All right, sample size and replication. What is sample size and why is it important? Sample size is the number of subjects. Well, it's important because if there are if there are too few subjects in the sample, then there's not enough information to make a general statement about the population. What is replication? Well, replication is the repetition of an experiment under the same conditions or similar conditions. Why do we care? Because if a study cannot be replicated, then the results are less likely to be accepted. By the scientific community, because they can't redo it. They want to be able to say, I can do that too. All right, 3 more. So the census is a count or measure of the entire population. I think we do it every 10 years, don't we? We're in the process of a census right now. Sampling is a count or measure of a part of the population. The sampling error is the difference between the results of a sample and those of a population. There's a formula for that, but we ain't getting into that. All right, so this is the end of part 2 of our vocabulary notes. So we went through 1 through 8 here. So for your homework, I want you to do this deciding on the method of data collection and go down through 9 through 13 here. So that's the next part of your homework here. Okay, so that's what you'll do for homework.